In this video, I'll talk about how to find products of single replacement, double displacement, and combustion reactions. During single replacement reactions, one element replaces another element in a compound. In a single replacement reaction, there is always an element and a compound. It doesn't matter which one you write first, the element or the compound, the result will be the same. There are two possibilities. One cation replaces another cation in the compound, and one anion will replace another anion. Copper plus silver nitrate, producing copper nitrate and silver. We start with deconstructing, dividing the compound into parts in cation and anion. NO3 is a polyatomic ion with one negative charge here. And the copper, which positively charged, is combined with NO3, which is negatively charged. So plus minus reacting together, and silver is displaced from the compound. Another example is when an ion replaces another anion. Chlorine combining with sodium bromide. Chlorine is displacing bromine. Since chlorine is more reactive than bromine, then we'll have sodium chloride and bromine, which is released, which is displaced from the compound. Aluminum reacting with magnesium chloride. There is no reaction in this case because aluminum is less reactive than magnesium and cannot displace magnesium. The same story for magnesium chloride with the bromine. Bromine does not displace or replace chlorine because bromine is less reactive than chlorine, so there is no reaction. How do you find which one is more reactive and which one is less reactive? You need to check the activity series, which is a list of elements in decreasing order of their activity. The metal above is replacing the metal below, but the metal below is not replacing that above because this is more reactive than aluminum. So on the top of the list, we find the elements, metals, which are more reactive. The same for halogens. Fluorine is the most reactive, then chlorine, bromine, and iodine. So bromine in our examples here does not replace chlorine in this compound. Cations formed from elements of group 1, group 2, and aluminum, group 13 or 3, they will replace only one hydrogen from the water molecule. So we'll have potassium hydroxide and hydrogen when potassium reacts with water. Next, double displacement reactions. During double displacement reaction, the cations and anions of two different compounds switch places. Double displacement reactions tend to occur in aqueous solution. Not all ionic compounds will react with one another. We have a double displacement reaction when we see a solid precipitate formed and when we see a gas which is produced during the chemical reaction. Double replacement reactions tend to occur in aqueous states, aqueous solution. To find the product, you need to deconstruct the compounds. Here we have to deconstruct this, to divide this compound in two parts. In a cation, hydrogen is plus, is a cation, and SO4 is a polyatomic ion with two negative charges. On the other side, we have barium, positively charged, and chlorine, negatively charged. Now, the outer parts join together, combine together to form hydrochloric acid. The inner parts, which are have opposite charges, join together to form the barium sulfate. Here's another example, which is very similar. Deconstruct, divide into cations and anions, and then connect, combine outer parts and the inner parts, and you have the final products. And another example here, when we have a precipitate, is when we have sodium chloride and silver nitrate. You deconstruct, divide them into cations and anions. Cations join anions, so negative charges attract each other, and the inner part join together, and we have a precipitate here. So both these are in aqueous states, and you see a precipitate when you do this chemical reaction. Combustion reactions. In general, combustion reactions are reactions of oxygen gas with anything. In this video, I'll talk about combustion of hydrocarbons, carbohydrates, and alcohols with oxygen. Here is the pattern. So a hydrocarbon with oxygen, you get always, all the time, carbon dioxide and water. Remember this. Here's another hydrocarbons. Hydrocarbons are made up of two elements, hydrogen and carbon. Carbohydrates, and glucose here, which is the cellular respiration plus energy. It's a same, we have carbon dioxide and water's product and a lot of energy which we need to do work. And alcohols, same, acting with oxygen and producing carbon dioxide and water. So you need to remember the end products are carbon dioxide, water. Whatever you join on the left, you'll get two products, carbon dioxide and water, on the right. Another type of reaction is incomplete combustion reaction. In this case, you have not enough oxygen, and except for carbon dioxide and water, you'll get the carbon soot, and you'll get the carbon monoxide, which is a poison. Thank you for watching the video, and if you find this video helpful, please like and subscribe.